Assalamualaikum warahmatullahi wabarakatuh. My name is Prakasiwi Sujadi from the IEL class, and now I'm going to present about my final project, which is the PLC-based electropneumatic controller. So, a PLC-based electropneumatic controller is a system that combines a programmable logic controller, or PLC, with pneumatic components to control and automate the operation of pneumatic devices or systems. This type of controller is commonly used in industrial automation applications. The components used and the function is first is the PLC itself. It receives input signals from various sensors, processes them based on the program logic, and generates output signals to control pneumatic actuators and valves. Second is the pneumatic components, which consist of pneumatic cylinders. These devices use compressed air to generate linear motion, commonly used to actuate various mechanisms in industrial processes. Also, the pneumatic valves. These valves control the flow of compressed air to actuate and deactivate pneumatic cylinders, and also the air preparation unit. It consists of filters, regulators, and lubricators, or the FRL, to ensure clean, regulated, and lubricated air supply to the pneumatic components. Third is the control program. The program defines how the PLC responds to sensor inputs and generates output signals to control the pneumatic components. And fourth is the human machine interface, or HMI. It is an interface between the operator and the PLC based electropneumatic controller. It allows the operator to monitor the system status, change settings, and provide manual control if required. So there are two methods to control the cylinder in a pneumatic system, which is the time method and sensor method. And in this project, I use the time method. In the time method, the piston on the cylinder moves after a specified time is reached. In the time method, we can use the TDR, or time delay relay, and PLC components by using the timer facility. So here is the two-cylinder controller electric network using fluid sim. And designing the ladder PLC program, it is better to simulate it first in the fluid sim application program. Using TDR, making an electropneumatic circuit in the fluid sim application will facilitate the creation of the ladder PLC program in the CX programmer application program later. So the electropneumatic controller series using the fluid sim application program uses the CDR component as it is shown in the picture of the series shown. If the start button is pressed, relay K1 will activate and the context change position. Lock Locking will lock the start button, or the start button has no effect anymore even if it is not pressed, because contact key 1 changes position from open to closed. Timer 1, or T1, will be active or working, and timer will change position for a specified time on this circuit is for 5 seconds. After 5 seconds, T1, then timer 2, or T2, will be active or working as well, and the timer context will change position for the specific time on this circuit is for 5 seconds. Likewise, the with the T3 and T4 timers. And here's the ladder diagram in the CX programmer. The input terminal with addresses 00 is connected to push button no, and input address 01 is connected to push button NC, while in the output terminals address 00 can be connected to indicator lights as a marker of the system is running. For the output of address 01 is connected to solenoid S1, output address 02 is connected to solenoid S2, output address S03 is connected to solenoid S3, and the output address S04 is connected to solenoid S4. So for this project, we can conclude that the PLC-based electropneumatic controller combines the power of a PLC programmability with the versatility of pneumatic components. It provides a precise control and automation of pneumatic system, improving efficiency, accuracy, and safety in industrial processes. The specific design and functionality of the controller may vary depending on the application requirements and the component used. And that's all from me. Thank you.